So the right side, if you take that left brain, right brain analogy, left brain being more the computer, right being more connected to your emotions, the right side has more control of your emotional responses, which is going to be, I see we have somebody falling, one of the females is falling. She's going down, 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 down. You're not, you start yawning, then the yawn goes around the room. The right nucleus ambiguus is the source of the right vagus, which provides control over the larynx. SA node of the heart controls vocal intonation, cardiac vagal tone, therefore it's myelinated. It's going to be involved in the social engagement system. Right central nucleus of the amygdala has direct influences over the right nucleus ambiguus and promotes laryngeal and cardiovascular responses associated with emotion. In other words, where we're going with this is the emotion that I'm picking up from you and the environment, the tone of your voice, the nature of your voice, how I see your face. You know, I'm gonna start to get a complex and think that I'm just a boring person. If you fall asleep, I'm gonna kick your ass because you asked me to do this lecture. The right central nucleus of the amygdala influences your larynx, your cardiovascular responses. That you take it from the environment. Stimuli that are processed primarily in the right hemisphere are responsible for your cardiovascular responses that are stimulated by the left hemisphere. Damage to the right hemisphere blunts facial expression with vocal intonation and autonomic reactivity. I read another book, really interesting, like easy reading, called The Man Who Mistook His Wife for a Hat. Did I tell you about that book? It's written by Oliver Sacks, famous neurologist. When you get left brain lesions, tumors, things in your left brain, you lose abilities. Lose abilities to do math, calculate this and that. When you get right brain lesions, they're very weird. You hear music when music isn't playing. They're very abstract, different conditions when there's right brain lesions. So it's a book of right brain lesion stories. You see in the movie 50 First Dates, where the guy has an anterior grade amnesia, it's a right brain lesion. Okay? And the story is called The Guy Who Mistook His Wife for a Hat, because he had a college professor. And he would show him a picture, and the professor was able to tell him about the picture, but he actually had no vision to see it centrally. So how the hell could he do it? And he said he was fine. So then when he went to go, he grabbed his wife by the hair, kept trying to put her on his head. He said there's no problem, but he thought his wife was a hat. Interesting book. Okay, back to the boring lecture at hand. Mammalian embryological research. Primitive gill arches evolve into muscles. We just did that. Okay, so the face, bones, the mouth, jaw, larynx, soft tissue, palate, esophagus are all going to develop from the higher arches, and then that's going to be buried with nerves that are going to be involved in social engagement in your myelinated vagus. So your trigeminal, facial, glossal, vagus, and accessory nerves. These are all going to be part of the higher vagal response. These muscles are not innervated from the anterior horn. Okay, they don't have that cell going down from the anterior horn like your upper motor neuron, anterior horn, and then out to the effector site. These are all corticobulbar connections. Corticobulbar means they're going directly to the hind brain for quick execution. Polyvagal emotion. He has literature that documents the link between right brain function and more emotional side that's documented. Medullary source and nucleus ambiguus are lateralized to more on the right side, more emotions on the right side, and more output to the heart happening on the right side. There's special visceral efferents which provide behaviors used to define emotion. So trigeminal and facial nerve are going to be involved with facial expression and vocalization through your stapedius. I'm looking at you. No one behind you. I'm just looking at the gold outfit. Visceral efferents have a right brain bias, also regulated the bronchi, heart, and organs that respond to stress. you have one vegetative system, your lower system. Your other system is sort of like a smart vagus. So you have unmyelinated vagus, sympathetic nerves, and then you have a smart vagus, which is myelinated. That's for social integration, paying attention, motion, sounds, and emotion. Primary emotions, fear, anger, happy. These are related to autonomic nervous system functions and survival. And they are necessarily, if they're important for survival, they're integrated into the cardiopulmonary system. Why? Because if I need to do some quick activity, the cardiopulmonary system has to immediately be activated or deactivated. Emotions transcend within medullary structures, controlling visceral function, have right brain bias as well. Jacksonian dissolution, you've heard me talk about this idea before. You have the brain functioning on different levels, from being a baby to starting to be emotional to starting to calculate things. And then as the higher systems break down, the lower systems go, they never are offline. We just see them when the higher systems are not functioning. The higher centers, if you want, are inhibiting the lower centers. That inhibition is gone when the higher systems are gone. So we see positive symptoms caused by the release of lower centers, delusions, hallucinations. Lower operating systems are not actually discarded, but rather repurposed as higher systems come online. Another one more complicated slide. The ventral vagal complex, your higher vagus nerve, which is myelinated. This contributes to regulating the behaviors that we need to explore our social environment. I need to listen to things. I need to look at you for visual cues. Head gestures are also important. Specifically, somatomotor components of the VVC are involved to turn the head. These are nerves we talked about: trigeminal, facial, vagus, spinal accessory nerve. So turning my head, that's spinal accessory nerve. So I hear something, I don't know if it's danger, I have to listen. The stapedius is going to pull, that's coming off your chordae tympanae, number 7. It's going to tighten my eardrums so that I can tune into lower sounds. I'm going to turn my head toward the sound. This is all part of your social engagement system. So low frequency is conducted through bone, phylogenetically non-mammalians, and triggers danger DVC complex, unmyelinated vagus for flight, fight or flight, or immobilization. The visceromotor components of the VVC contribute to rapid modulation of vagal control of the heart and bronchi. Either the heart and lungs are online or they're offline. It's going to get slightly easier. So this is what we've been saying over and over many different ways. Unmyelinated vagus, it's coming from this part. This is where the nucleus is coming off the brainstem. You don't need to know where it is. All I can do, if I have that, is I can pretend I'm dead, shut down completely. If I am, this is an evolutionary thing, if I'm higher on the evolutionary ladder and I have a sympathetic system, I have the choice. I can either shut down or I can mobilize, avoid, attack, whatever. Myelinated vagus allows us that moment of decision making based on my environment. Myelinated, and unmyelinated, you can break it down this way. This black line, everything below the diaphragm, that's unmyelinated. It's your lower phylogenetic orders, and the higher species, this is all myelinated, everything that's above the diaphragm. So there's a fine discrimination. So your social environment gives you some input, goes into your cortex, goes into these cranial nerves for social engagement, trigeminal, facial, glossopharyngeal, vagus, spinal accessory. So that, I don't know how mastication fits into it, but you can pay attention, look at facial cues, phonation, head turning, heart and lungs are online. Interoception, this is another term that he uses. Externally, we have our 5 senses: hearing, taste, sight, smell, vision, hearing, touch, smell, and taste. External sensations, he says, they're not the whole source of stimulation of infant behavior. Thoughts and emotions also are. He says we have, and he calls them interoreceptors on our heart, stomach, liver, and other organs that send afferent information via the vagus nerve. Remember, the vagus nerve is 80% afferent information. The vagus nerve is going to all your organs. So it's taking that information, it's taking that information of the internal state of those organs and doing something with it. He says that this is crucial to the infant's survival and development.